Okay, in this lecture we are going to see exploratory data analysis in data science. So let us be ready. We will see with example now. This is the example of a student's record in an engineering college. Okay, we are taking 10 examples. Different students branches, first semester, second semester. Their subject 1, subject 2, subject 5 marks, total average grade, and we will also put some missing value. So let us see this, and finally we will find a correlation between the subjects total average. For that, okay, we will see data exploratory analysis. What is exploratory data analysis? Data Science EDA, we name it EDA, exploratory data analysis. Okay, so what is EDA? EDA is like being a detective with data. It is a process of examining and understanding your data before making any conclusion. Think of it as getting to know your data, what it looks, what pattern it has. So you can see the output here. Okay, so why do we need this? Understand your data, find a pattern, discover hidden relationship, spot problems. It may happen that your data may have missing value, it may have some outlier, incorrect data, and make better decisions based on conclusions, on facts, not assumption, and plan next steps. Okay, real world examples where EDA is used in schools, analyzing students' grade to improve teaching methods. In hospital, understanding the patient data to provide better care. Or Netflix, analyzing viewing patterns to recommend movies. In sports, analyzing player performance to build better teams. In weather, analyzing climate data to predict weather. So these are all real-time examples where exploratory data analysis is used. So already I told you we are considering this data set. And we'll see the example. We'll import required libraries. Then we'll load data, step 2. Then we will look at the data. Then we'll clean the data. We'll find data types, its information, its missing value, null value. Then we'll find the statistical information. And we'll see with the help of examples. Finding patterns, branch-wise analysis, grade distribution analysis. Next is find insights and pattern. And let us see the code now. Okay, let us jump to the code. So this is the data we already created. You can see this. Okay. So before that, we need to import the library. Import Pandas as pd. Import numpy as np. Import matplotlib.pyplot as plt. Import seaborn as SNS. And we are here setting the option to plot the graph. Okay, when I run the code, you can see it is tick mark. So next is code block to load the data. So here we have created this data set, that understands. This is the data set, okay, that we have created here with the help of dictionary. Data equal to student ID, name, branch, semester, academic year, college name, level, subject 1, subject 2, subject 3. All these are columns in the Excel sheet, okay, that we created. So these are the columns that we created with their value. This is the name value pair, this is the name and this is the value. Okay, this is the list. So like that we created this data frame, and here we keep some value as null. Import numpy np.nan, null value. These are null value, missing values are there. Okay, you can see this. There are missing values for subject also. 1, 2, 3, 4, 5 subject values are missing. For subject 2, 1, for subject 1, 1. So like that we will also see how to calculate missing value and how to fill up that missing value to the other value. Okay, so we here created data frame equal to panda.DataFrame data is the dictionary, and data loaded. When I run the code, okay, I get the message data loaded successfully. Length of data is there are 10 records. Okay, next. So let us look at the record. First, look at data. First 5 rows of the data. If you see first 5 row of the data, and I'm printing this output with the help of this statement. Print in bracket equal to into 50. So what happened? This equal to get repeated 50 times. So that's why I get this output. Afterwards, print new line, first 5 row of the data. First 5 row of the data, and again 50 times I get the same line, and df.header. So when I type df.header, I get the first 5 record. You can see student ID, name, branch, semester, academic year, college name, and here level 1, UG, PG, PhD, subject 1, 2, 3, 4, 5, total average grade. Okay, for first 5 record, 0 record, first record, second record, third record, fourth record. So here I am getting first 5 record. By the help of function, what is the function name? DataFrame.header, df.head. Okay, what is this df? If you see, this is a df. Data frame is the frame. Data frame is the function. This import this Panda as pd, and we created this data frame. Okay, this data frame df, and this data frame is loaded here. df.head. Okay. Same df.tail, it will print last 3 records of the data. Last 3 records. Okay, last 3 record of data. This is the last 3 record of data. You can see this is the last 3 record. You can see record number 7, record number 8, record number 9. Okay, last 3 record. Then dataset information df.shape. How many rows and columns are there? If you see, there are 10 rows and almost how many columns are there? 10 rows and 15 columns. 15 columns in this data set. These are 15 columns. First, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the 10 row and 50 column. This is the size of data. df.shape, df.shape, then df.shape 0 row, df.shape 1 column. You can see df.row 10 row and 15 columns. Okay, next, data information types. Now I want to find the types of data. So here I got student ID is the object, name is the object. So what I get here? I get what is the type of object here. If you see, this is the integer, float. This is float, and this is the non-integer. So you can see this. Okay, subject 1 float, subject 2 float, subject 3 float. So all these numeric data are denoted with the float. Just check this. And all other non-numeric data are denoted with the help of object. Okay, so how do I get this? Using the function df.dataTypes. Okay, it shows all the columns of the data types of the column, missing value in each column. How many missing values are there? Okay, if you see the missing value here. Okay, how many missing values are there? So subject 1 9 non-null values. Okay, subject 4 5 non-null values. Means what? There are 4 values which are null in subject 4. How do I check? Let us check. Subject 4, 5 plus 4 9. So let us see. We have 10 records. Out of 10 records, 5 records are null for subject 5. Subject 5. See, this subject 5 is there. Subject 4. Okay, this is subject 4. Subject 4 is there. So let me check for subject 4. 10 non-null values. Sorry, 5 non-null values for subject 4. 5 non-null values. Just check this. 1, 2, 3, 4, 5. So it is counting how many values are assigned as null. What is meaning of this np.nan? These are null values. So here this function, okay, this function is printing the sum of all null value. df dot is null sum. It prints the sum of all null values column wise. Same for missing value. Okay, I get the sum for total missing value. How many values are there? For subject 1, 1 missing value, subject 2, 1 missing value, subject 4, 5 missing value, subject 5, 1, total 1, average 1. So if you check one more time the output, these are missing values. np.nan, 1 value, total n, this is missing value. So like that I got this output. Okay, these are missing value. How do I get? Using the function name is missing values dot sum. Okay, missing value. See, this is the missing value. This missing value equal to df is null sum and missing value dot sum. Okay, so next thing. Statistical summary. Here I get statistical summary. Means what is the mean, average, median, average. When I run the code, I get the output. Just check this. This is the when I df.describe, when I run this command df.describe, okay, I get this table. Remember, this is the output of only one command. What is the command name? df.describe. You can see statistical summary of numerical column. Okay, and here df.describe. df.describe. Clear? Remember this. Do not forget it. df.describe is very important command here. And afterwards, detail the statistics for student average. Here mean average, median average, highest average, lowest average, standard deviation, variation. Function is df.average mean. And here 0.2f means it will truncate up to 2 floating point. Number of decimal after point is 2. df average median, df average max for highest average score in that particular subject. Lowest score is df dot average minimum score. Standard deviation df dot average STD, and variance df dot variance. So when I run the code, I get this output. Mean value 83, median value 86, highest average 1494, lowest average, standard deviation, variance. Okay, let us go next. Now here I want to find average performance by branch and top 3 performing students. So when I run this code, I get top 3 performing students. Okay, average performance I get. What is the average performance of branch electronics, mechanical, CSE, civil, and what are top 3 performing students? I get these are the students in their branch who are top 3. Okay, overall top 3 students, not in branch wise, overall top 3. For that, the function is value. Value is the function name. Okay, so df branch value counts. Okay, what it will print? Number of students per branch. Okay, how many students are enrolled for? If you see this, how many students are there for CSE? 1, 2. Okay, 1, 2. For electronics, 1, 2. For electrical, 1, 2. To get this value, this is the function value count. So this df branch value count will count all the values branch wise. Okay, so that's why here I get in CSE 2, electronics 2, mechanical 2, civil 2, electrical 2. Okay, next is average performance by branch. So there the df dot group by branch, first group by branch, in that get the average column, get the mean of that average, sort that values in ascending order, and finally I get these values. Okay, average performance branch wise in ascending order. Okay, and next is top 3 performing students, df dot n largest. What is the function name? N largest. See, df dot. When I type dot here, I get these, all these are the functions. Okay, can you see all these functions? Aggregate, apply. Okay, so we are choosing the function from this drop down list and use this describe, difference. Okay, drop not, okay, drop null, then empty equals evaluate, fill null. Okay, so from that we choose n largest. We choose n largest dot n largest. Okay, if you go to this n largest, you will see this n largest here. I J K L M n largest. Okay, and from that we use top 3 and get by average. And when I get this, only get student ID, name, branch, average. These are the column names of top 3 students. So here I get these column names. Okay, don't get confused. Okay, so next. Grade distribution analysis means what? How many students have got A grade? How many students have got A plus grade? How many students have got B grade? How many students have got B plus grade? Grade distribution. Okay, percentage of grade distribution. 30% students have got A grade. 30% students have got A plus grade. 20% students have got B plus. 20 students have got B grade. 30 plus 30 plus 20 plus 20, 100. Students with A plus grade. Okay, top students with A plus grade, these are the students. So how to get this? For that the command is df dot grade values count sort index. Okay, it gives all the values, okay, grade wise. Same for grade distribution percentage, df dot grade value count normalization equal to 2 into 100. This is a formula, round one. Okay, you get grade distribution means how much percentage of the students have got that grade. Next is student who got A plus grade. So filter df dot grade equal to A plus. Okay, filter all these record, and once I get this record, I want only student ID, name, branch, average, 4 column only. So using this I get this value, ID, name, branch, average. Okay, so in this way I got the students, top students. Okay, next, students who might need extra help means what? When you see the output, students who might need extra help below 75%. I want to print all the students whose marks are below 75%, means Anita Gupta and Rohit Verma. For that the query is there, df average less than 75, filter that record by this condition, and once you get this record, get these 5 columns and print it. That's it. One line syntax. Same for branch wise performance analysis, group by branch. Okay, then average, find mean, sort values, ascending fast. Okay, and next is level wise performance, UG versus PG. You get the output here, level wise performance, UG versus PG. We see UG, actually this is UG, this is PG. Okay, last is semester wise performance, df group by semester, and here I need only average, only one column, mean. That's why here I got only one column. So in this way we have covered these concepts here. The most important thing is here, these are all common scenario purpose. Okay, we load the data loading is there, import the dataset into Python using Pandas. Why it is important? To bring the data into memory for analysis. Example is panda.read CSV file, data.csv or read data frame. Here we created data frame and read the data here. We can read Excel file also, or we can read the database into Excel file and we can import the data here. And data overview, check, look at first few row and shape. Okay, to know data set size and structure. For that we need data frame head, shape and info. Missing value is there. Find null values in columns. Missing data can cause wrong results or model errors. So how do we find missing value? df dot is null sum. It shows how many missing values in each column. Okay, so do not forget them this syntax here. Examination, it's important. Duplicates, check for repeated rows. How many rows are repeated? Duplicates can be bias analysis or infinite statistics. So df dot duplicated sum. Data types check, verify each column's type. Ensures numeric column are treated as number, not string. Okay, df dot data types. Summary statistics. Describe numerical data only. Understanding central tendency, mean, median, mode, and spread, standard deviation, variation. For that function df dot describe. Outlier detection. How to identify outlier detection? Using this flag. This is seaborn. Yes, import seaborn as SNS. SNS dot box plot data frame subject one. Okay. Here box plot z score method, IQR method. Okay, outlier affects averages, correlation, and model performance. So here outlier detection can be done using this function. We'll see everything. We have seen everything practically. Correlation analysis. Okay, there are relationship between two variables. So we find this with the help of DataFrame.co and plot that graph. Or we can use SNS heat map also. Distribution analysis. How data is distributed? It's normal, skewed, etc. Reveals imbalance, skewness, and data pattern. For that function SNS.histplot data frame average. Feature relationship. Compare one variable with another. You can check here. When I see this code, I can easily see which values are related with other values, which values are not related. Okay, for that we need which one? This scatter plot. We need scatter plot. Okay. Category analysis, analyze text and category data like branch and grade, understand frequency and category influence. Okay. For that we have to df.branch value counts. For using SNS also we can do it. Group analysis, aggregate data by categories. Okay. Means here UG student, PG students, or your branch wise students is there. So df the group by level, average mean. Okay. Next is visualization setup. Visualization setup means how do you plot the data. Okay. Next is trend analysis, time based. Analyze how data value changes over time. For that the function is plot data frame here. Then data cleaning is there. Fix incorrect data types, missing value or duplicate. Prepare dataset for modelization and visualization. For that the function data frame dot fill NA 0 or df dot drop duplicate. Okay. And finally export results. We are exporting the results, save clean data, analyze data, reuse results and share insight. For that df.toXL new data file. And these are the common plots that you will see in all data science EDA. Histogram plots, box plots, scatter plot, heat map, pair plot. Okay. Then your bar chart, pie chart. Okay. These are the graph type and used for load distribution, data distribution, box plot for outlier detection. Remember, it's very important. You should know which graph is used for which purpose. Box plot, outlier detection. SNS dot box plot. Here, scatter plot is there. Relationship between two variables. SNS dot scatter plot. Okay, we create variables relationship here. Heat map is there. Correlation between many numeric columns. The syntax is SNS dot heat map. DF correlation. Okay. Next is pair plot. Pairwise relationship. Here we create the plot with the help of SNS dot pair plot. Subject 1, subject 2 total. Okay. Bar chart is there and pie chart is there. So here you just pass the bar chart and pie chart. So in this way we have finished this. In next lecture we will see the same thing with the help of graphs. Okay, you can see different graphs are there. In next lecture we will see. Thank you.